Hello, my name is Anton Kolonin. Today I'm going to tell about the work that we are doing at Autonia Foundation with involvement of Singularity DAO and Singularity Net. And this work is dedicated to develop adaptive multi-strategy market-making agent architecture. In fact, we are working on larger scale infrastructure for active portfolio management based on artificial intelligence. And we are doing R&D in multiple directions, where the primary focus at the moment, which will be presented today, is to be able to do adaptive market making, trading, and active portfolio management based on the market simulation and backtesting. Potentially, it can be done both off-chain using kind of Binance limit order book system, or on-chain using smart contracts like Uniswap or Balancer. But our current work presented today will be focused on off-chain market making on Binance. Also, we are working on different things like price prediction, and some results will be presented in the very end. We're also working on sentiment analysis, on chain data analysis, but that's not the part of this talk. If we approach the problem of the active portfolio management, you can think of the problem as optimization as a problem in two-dimensional space, at least two-dimensional space. And these basic two dimensions are about different assets or instruments that you use for your portfolio management and different strategies that you apply to these instruments or assets. Like you can imagine this as a grid where you not only allocate different percentages of your portfolio to different instruments or assets, but you also involve different fragments of your portfolio for being involved in different strategies. Like you can be holding something, you can be market making on Binance, some percentage of your investments, and something may be traded on Uniswap. But right now we will be focused only on the market making on Binance, and we will be focused on doing this with single asset or single currency in mind. Although the work that I am presenting potentially can be extended for multiple strategies and multiple assets. If you think at the active portfolio management problem as a whole, you can see that there are multiple kinds of activities are involved. Like based on your investment goals, first you need to build your portfolio, selecting particular assets and exchanges where you want to trade these assets or do market making on these assets on such exchanges. Then once you have your portfolio, you need to keep rebalancing it and in respect both to assets and strategies applied. And finally, when you have these strategies, you need to make sure your strategies are executed in the right way. Like if you are trading, you need to account for timing and when you need to do the trades, like such as buy and sells, and what would be the volume, and you might need to do some prediction capabilities in order to select the volume and time for doing the trades. And for market making, it gets much more complex because besides the time and productivity and volume, you need to account for spread that you need to set in order to mitigate the risk on your market making activities and avoid impermanent loss. You need to consider the fees that may be applied to your market making activity. You need also to consider that you might be trading the market making by multiple bots using grid order systems or staggered orders, so you can actually allocate your orders at different levels of the order book. And in order to do that, in order to do any of these activities, you can actually rely on different sorts of what we call AI oracles or AI services or AI servers, like signal generation, price prediction, portfolio weighting, strategy evaluation, and so forth. Getting into detail of the infrastructure that we are creating right now. you can see that at the lower level of our infrastructure, we need to collect the data. So we have the market scalping to collect the market data. We have the news scalping to collect the media data. Then the sentiment and the pattern analysis is doing sentiment analysis based on the media data. The market data is used to predict the price and volatility. And then based on the sentiment patterns and price and volatility, you can generate the signals, and the price volatility and market data can be also used in the simulation and backtesting that you may run to evaluate your strategies before actually applying your strategies on the real exchanges to do real trades and real market making. And simulation and backtesting will be important part of the today discussion. And at the very top, relying on all that infrastructure, you see all these sorts of activities that we just have mentioned today. As parts of active portfolio management, you can do portfolio planning and portfolio balancing, relying on services by all this infrastructure. And finally, you may be doing trading and the market making, and the market making agent and architecture and design and performance of the market making agent, which is sitting at the very top right in the corner, will be the subject of today's talk. Now let's go straight to the purpose of the to the main focus of this talk. So since the talk is presented on the Artificial General Intelligence Conference, or AGI, so let's consider the problem of market making as a narrow AGI problem. So we want to think of this problem as AGI as long as we just represent the problem in a formal space where we have some base values possessed by the agent, where the base values may be grounding some models that agent infer based on the interaction with the environment, and the models are informed based on some observed evidence that agent observes by means of the perceptions that he is able to percept. And based on these perceptions, agent is relying on inferred models, referring to base values, and generates some actions and logs these actions into the directed action log and directs the actions out to the environment. In order to manipulate with all of this data, you can imagine a few different activities that agent should be able to perform, like it should be able to predict the data, the events in the environment based on the observed evidence. So there is a predictor which can build inferred models. Then there is a decision-making system which takes the inferred models, currently observed evidence, refers to the base goals, and makes a decision which have to be directed to the action log and to the outer environment. And finally, there is a compressor component which just takes care about the memory capacity and consumed resources, so it gets rid of unnecessary data and minimize amount of information stored, so that only valuable and relevant and salient models and evidence are preserved for the agent operations. Well, in our specific case, we also have supervisor, which can actually inject or derive the base values. So in order to be profitable, we want to explicitly tell our agent that it just need to have high returns and low losses, and that's the base value of our agent. It doesn't need to be happy, it doesn't need to leave offsprings, it just needs to have high returns and low losses. And then we need to define the operational space of this agent, so it would have particular kinds of perceptions, like high level of the price on the specific market or low level of the price on the specific market. And it has to be able to direct particular actions, like create ask orders or bid orders. And that's the world where our agent live. And given we can identify such operational space, which such specific environment, where environment is specific to the market making on crypto markets. Then we can identify this problem as a narrow AGI, where the scope of the narrow AGI is market making. Here we can see the larger view of what we call operational space. We have the same market making agent in the middle, and here at the top left you see the data that it could be able to percept. It could be market data like OHLCVs and trades and limit order book at different levels, and it can potentially also percept the media data like news, Reddits, subreddits, feeds, and so forth, and RSS feeds, tweets, which it can use to analyze market data. Unfortunately, having all this analyzed gets too complex, and we don't want to have our poor agent to analyze that level of and that volume of data at the moment. So we are considering that this raw data is pre-processed by some pre-processing functionality or feature building layer, or some classification systems which can classify, for example, positive or negative sentiment, and we end up with building some metrics or signals which can apply for market, like price difference, log returns, different indicators like volatility, standard deviation, SMA, CMF, sell buy imbalances, ask bid imbalances, and also some media indicators like sentiment and cognitive behavioral therapy distortions that can be also extracted from the news media files. And then all of the data can be fed into the agent as a perceptions. On the other hand, when the agent has to act against the environment, it can do it in a few different ways. Of course, it can directly take some actions in respect to the environment, like create, ask, and bid orders, cancel orders, buy particular assets at in particular size, or sell them at the current market price. The problem that then the action space becomes too large with too much permutations across different combinations of these actions, because when you are considering that ask or bid have the price and the size arguments, you can imagine the whole range of sizes and prices, and the space of the possible values of the parameter of the actions that you can imagine based on permutation of all possible prices and all possible sizes is enormous. So we don't want to go this way. We want to simplify this, and we want to simplify it by means of introducing the notion of the trading bot or trading policy or strategy, which can be run automatically driven by smaller number of parameters. Like we can configure a bot which would automatically create ask and bid orders, cancel order respective orders, buy and sell stocks at different conditions, driven by limited number of parameters like spread, percentage, cancellation policy, refresh time, and so forth. And then we have significantly reduced action space, and that's the way we are going to proceed in this work. And that's the way we do it right now. And actually, right now in the work that we are presenting today, we are making it much simpler. So there is just one metric and signal that agent can consider. That's the price difference. And there are just two parameters that agent has to care about. That's the spread and the cancellation policy. So all of the experiments presented in this work will be just done in such oversimplified operational space with still quite reasonable results. In practice, you can see the design that we are currently employing. So in the middle, you see the same adaptive multi-strategy agent, which can do two interesting things at the same time. The single agent can have a population of the single strategy agent. That means you can consider that this adaptive multi-strategy agent is kind of supervisor or a farm of multiple bots where each bot is executing one very specific strategy. And these real specific bots are making real market making activities on the real exchange under control of the adaptive multi-strategy agent supervisor, which gives them the parameters which drive their operations, and they return real profits and losses to the supervisor. However, at the same time, this multi-strategy agent can run much more single strategy agents in the virtual environment, because it gets quite inexpensive to run agents in the virtual environment without of having real losses in such a way so that the supervisor can evaluate all imaginable strategies without of getting involved into the actual losses. And then all of these hundreds and tens agents that are trading on virtual environment can be doing a virtual market making activity on the simulation and backtesting framework, how we call it. Then they would be returning virtual profits and losses to adaptive multi-strategy agent, which can then do selection of this single strategy agent and their parameters based on their performance, and then the most successive ones would be used to actually get replicated in the single strategy agent. So we select the most successful and profitable parameters periodically, like every day or every hour or every minute or every month, depending on our configuration. And then we keep updating the small subset of the single strategy agents that are trading on that are doing market making on the real exchange based on what we see is going in backtesting mode. And of course, the simulation and backtesting framework is operating on the same market data which is being generated by real exchange in the real time. So that's the overall design. And in order to proceed further, just let's see the architecture of our simulation and backtesting framework employed for this purpose. So that's effectively the block diagram represents the actual class structure of our system. So we have the simulator block layer, we have the environment layer, and the environment layer contains the exchange simulator, where every exchange can have one or more market or pair being traded on it. And then we have the agent, the multi-strategy agent, which have multiple parameters on itself and which drives its own operation. And besides these multiple parameters, it has a list of the micro-strategy agents, each of these agents have an individual set of parameters under control of the macro-strategy agent. And then all of this simulation is run either on top of the simulation agent, and the simulation agent just simulates the market from the scratch. It just considers that it just needs sufficient amount of the trading agents and the market making agents, or it can be a backtesting agent. And in a backtesting agent, we actually read the input historical data from the real exchange. That's centralized Binance exchange in our current study case, and then it uses backtesting engine to execute the real historical trades against the real historical orders being mixed with the orders and trades that are initiated by the agents that are being simulated. And well, of course, the results of this backtesting and simulation can be written to other artificially generated market data which can be in turn further used for other backtesting. And here you can see how it works. For example, here you can consider a period of 6 days, actually 8 days, where in the first 2 days we can take the macro strategy agent or multi-strategy agent to evaluate the performance of the all possible agent configurations and select the ones for the second 2 days for the second period. and during second two periods the agent is doing backtesting for all subordinate agents, for all of them, and real trading for subset of the agents selected from the first round. And on the third round, again, it selects the winners from the second round and makes the real trading with the winners of the second round, but still keeps the backtesting on all of the agents during the third round. And then finally, at the fourth round, it again reselects winners of the third round and makes real trading with the winners. For comparison of how it could work, you can see the two bar charts. The top bar chart renders how the results are of the simulation of the backtesting are obtained by population of individual agents. So the middle diagram in the middle have the profits on the right, green, and losses in the red, on the left, and you have different agent configurations. So the numbers are indicating the spread. The names of the agents like phlegmatic, sanguine, and choleric indicates the order cancellation policy, like phlegmatic never cancels orders till they are executed. So that's kind of hanging order strategy. Sanguine cancels orders only if the price direction changes and never changes the orders if the price is going in the same direction, even if the price is changing significantly. And choleric always cancels the old orders and creates the new one, no matter whether the price direction changes or the price level is changed. And here you can see that, okay, so we see the hodler is losing, and then some of the agents are winning or getting profits, they are green, and most of them are losing, so they are in red. But if we replace this population of 20 agents with single market multi-strategy agent at the bottom, and we let this multi-strategy agent not let all of these 20 guys to do the real trades at the same time, but it just watches what they are doing in backtesting on the previous round, and then select just the best one for the second round and doing it the round after round. You can see that there is a significant return, and this adaptive multi-strategy agent is able to earn significantly more than hodler is losing during the same period of the bearish market. Also, you can watch the development of this story in the real time. So here is the result of the dumping of the internal adaptive multi-strategy agent memory and budget periodically over the time. So in the middle you see the same market history for the first day of this October, by the way, October last year. So what we are doing right now, we are starting to evaluate this design for the whole year, starting October 1st last year. So we are at the very beginning of this work, and in a couple of months I think we'll see some interesting results, but that's just the first 6 days, and 2 days are just warming up for the beginning. And you can see that if you see cumulative ROI, return of investment, then in the first 2 days we are winning substantially. Then in the next 2 days it doesn't change much, and in the last 2 days we are winning much more, even though the market is going down in the last 2 days. And you can see that compared to hodler, we are still having not only the positive alpha, but we have a return while the hodler is losing. And at the bottom you see the same incrementally. So here you see that indeed in the first 2 days we are winning a lot, then we are losing a little bit, and in the last 2 days we are winning more than in the first 2 days. If we are not happy enough with the level of detail, we can see how it actually works and get some insights of what is going wrong. and actually I will just give example of what we have seen and what we are doing next from this point. So at the very actually here you see two levels of the returns, and the heat map indicates the profits and losses. So the green is amount of profit and red is amount of loss. At the top you see what is happening in virtual market making mode, so what is done by the backtesting side of the adaptive multi-strategy agent, and at the bottom you see what is happening in real time. By the way, when I am talking in real time, that's still on the backtesting. So since we are working with 2020 data, 12 months ago, what we are doing is that we are doing backtesting, and we are doing backtesting inside of the backtesting. So we are running backtesting engine with real agents, and one of the real agents is the multi-strategy agent, and this inside of this multi-strategy agent there is another backtesting engine which works on the same on the same historical data. But when we move this to production, if we validate this data on the whole 12 months, then in the real mode there will be just one trading process. The agent will be trading right on the real exchange, but still will be doing the backtesting internally based on the data being streamed from the same exchange. Okay, now back to low level detail of what is going on. So first 2 days warming up, 2 days before the October 1st. Now at the bottom you see that nothing is happening on the first 2 days. So no agents are trading, but everyone is trading on the backtesting side. And during the backtesting, we see that one of the agents is winning. So for example, you see that the agent phlegmatic is winning, and then you can, it is being selected. So you see the green arrow, and it is being used, as it is being selected, it gets used in the second round of real trading, and it gets the huge profits. So the choice was done right. The right agent was selected in the population. Now let's see what happens on the second day. On the second day, we are also doing the back testing, and we are selecting two agents. One, actually, we are selecting all of the agents who are getting the positive returns, but I am just considering a few agents to explain the way we reason and interpret this data and get some insights. So on the second 2 days, we select the agent phlegmatic 0.8 and choleric 0.2 because they are both winning, right? So along with other agents, they are selected, and we see what happens. So the choleric 0.2 is indeed getting us profits. So it was the right selection. But the agent phlegmatic 0.8, who was thought giving us the same level of profit, on the next round is giving us losses. So that's because the market conditions are changed, so we weren't able to guess it from historical data. So we thought that the market will be the same, but the market is different, so another strategy would better get required. So then, okay, so on the next day we again look on the next round, we again see who is doing good in the backtesting mode, and we see that there is one who is getting great profits, and we are selecting him or her for the next round, and this guy gets the bank. So again, that's example of the right choice. So by the way, doing this kind of analysis, what we just decided right today, we decided that actually when we do selection of the agents, we need to select them not only based on the performance on the backtesting, but we also need to combine it with performance in the real trading. So that means if the agent is winning, providing positive returns and positive alpha on the backtesting, but provides negative return or negative alpha in the real mode, then this agent is not selected. So now we're enforcing selection criteria so that only agents who are earning the positive alpha and positive return in both backtesting and simulation and backtesting and real mode, they are selected for the next round. Here is a summary. The summary is done using three different regimes of the strategy evaluation. Like at the top, you see the results when we are updating the strategy every day. Here in the middle, we update the strategy every 2 days. At the bottom, we update the strategy every 3 days. So what we see here, and we do that either on hourly basis. So the left 3 bars are for hourly simulations, so refresh rate or for order closing or creation is 1 hour, and on the right it's minute. So every minute the orders are have a chance to be created or closed or cancelled. So what we see here, so on 1 day strategy update interval, well, we see that the hourly, so that, and by the way, for each of the 3 bars on the left and on the right, we compare to 3 things. First of all, we consider hodler. So as you can see on both minutely and hourly, and no matter what the days, how many days we need to wait till update the strategy, hodlers are always losing the same amount of money. Okay, but besides the hodlers, the second bar is about what we would earn or lose if we were not doing this adaptive selection and evaluation. So the blind grid market making means that we just have all collections of the collection of the agents that we are considering to be used for adaptive market making, and just let them all trade and see who wins and who loses. So for example, here we see in the left top cell for 1 day strategy update interval for hours. Here we see that blind strategy gets less expensive than adaptive strategy. Well, so don't need to update strategy too often, that means. Then still for minute level market making, the blind grid gets really expensive, and we can earn a lot using adaptive grid market making. If we evaluate strategy every 2 days, then we can get positive alpha and positive return by multi-strategy agent for both hourly based and minute based market making. And if we further increase the strategy update interval greater, then we can see that, well, okay, so we are on hourly interval strategy, hourly market making, we are earning positive return on positive alpha. On the minutely, we have positive alpha, but still we are losing. So that means few interesting things. That first of all, we still have something to optimize, so we get rid of the need to optimize parameters manually, but we need we have a problem to figure out what is the right number of days to update the strategy. So in order to, we'll be looking into this further. So maybe what we need to have the number of days to be part of the strategy being evaluated by the agent itself, so you can actually further evaluate different strategies, super strategies involving a different number of days, or we might just involve the prediction capabilities. I didn't mention that all what have been shown before is done without of being able to predict the market. But what we are doing else, we are trying to use LSTM and LSTM ensembles to predict the market price. And here you can see that even without of being involved in these multi-strategy evaluations, you can get profits. And here is what you see. So here is the same similar 6 days market interval just for June this year, so that's another time interval. And here you see the losses and profits for different agents. In the top sections of the bars, you see the agents who are not doing the predictions. So that's we call blind grid order grid trading. So all of the agents are trading, we are not selecting them, but the top half of the agents is not doing any predictions, and second half of the agents are doing the predictions based on the LSTM ensemble for the price direction and price level change. And what we see here is that in the most of the days, on the first 2 days and the second 2 days, the agents who are who are using predictions, they are always winning, and they are winning more than non-predictive agents. And on the first day, non-predictive agents are even losing, but the predictive agents are winning over the hodler. Unfortunately, in the third day, third couple of days, it doesn't work well. So the predictive agents are winning a little bit less than the hodler. But the next thing that we are going to do, we are going to combine this multi-strategy optimization and the predictiveness based on the LSTM ensembles. So that was the end of my presentation, and thank you, and stay in touch if you have any further questions to Autonomia Foundation. Thank you.